87% of AI agents are running without any security checks between prompts, and Google just fixed that overnight.
Wait, are you saying most agentic workflows have zero runtime validation? So we're covering how to implement these hooks, what events you can intercept, and real compliance examples?
By minute 4, you'll have working code for production-grade AI security. Let's get into it.
Welcome to the AI Daily Podcast, today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into Gemini CLI gets its hooks into the agentic development loop.
Stick around to the end for this week's headlines. Let's dive right in.
So Google just dropped hooks into Gemini CLI, and honestly, this feels like watching the AI arms race play out in real time. They're essentially copying Anthropic's homework here. Claude Code introduced this exact feature back in September.
Wait, hooks? Like Git hooks? What exactly are we talking about here?
Similar concept, yeah. Think of them as programmable checkpoints in your AI development workflow. So instead of just chatting with an AI assistant, you can now inject custom scripts at specific points when the AI is doing its work. Want to run a security scanner every time the AI generates code? Hook it in. Need to log what tools the AI is using? Hook it in.
Oh, that's actually pretty clever. So it's like giving the AI guardrails.
Exactly. And here's what's fascinating. This represents a fundamental shift in how we think about AI tools. We're moving from AI as a chat interface to AI as an integrated part of your development loop.
But isn't this just Google playing catch-up? You mentioned Claude already has this.
That's the thing. The speed of this copycat behavior is what's interesting. Claude Code launched hooks in September, and boom, 4 months later, Google has an almost identical implementation. The lifecycle events are nearly the same. The JSON configuration format is similar. They're not even trying to hide it.
Is that legal? Can you just copy features like that?
Oh, absolutely. You can't copyright a feature concept. And honestly, this rapid feature parity might be good for developers. Competition drives innovation, right? But it does raise questions about whether we're seeing real innovation or just a game of feature ping pong between Google, Anthropic, and OpenAI.
So walk me through a concrete example. How would I actually use these hooks?
Let's say you're using Gemini CLI to help refactor a legacy codebase. Without hooks, you'd prompt the AI, it generates code, and then you manually run your tests, security scans, whatever. With hooks, you can set up a before tool execution hook that automatically runs your security scanner on any code the AI is about to execute, or a post-response hook that logs all the AI suggestions to your compliance system.
That's actually huge for enterprise adoption. I can see compliance teams loving this.
And that's exactly why this matters. We're not talking about toy demos anymore. This is about making AI tools enterprise-ready, with all the safety rails and audit trails that real organizations need. Google's documentation specifically mentions running compliance checks and security scanners. They know their audience.
But doesn't this slow things down? If these hooks run synchronously,
Great catch. And Google even warns about this in their docs. These scripts need to be fast because they block the AI's response. Imagine waiting an extra 30 seconds for every AI interaction because your hook is running some heavyweight analysis.
that could kill the whole developer experience.
Which brings us to the real challenge here, balancing safety and speed. Coming up, we'll dig into exactly how these hooks work under the hood, what the performance implications really are, and why this might be the feature that finally makes AI coding assistants ready for prime time in regulated industries. All right, so let's get into the technical meat of this. Google's implementation gives you about a dozen different lifecycle events where you can attach hooks. Session start, before prompt processing, before tool selection, after tool execution, and so on.
How does that compare to Claude's implementation?
It's remarkably similar. Claude has events like before command, after command, on error. Google has pre-tool selection, post-tool execution, on-session error. They're not even trying to differentiate. But here's where it gets interesting. The execution model is subtly different.
How so?
Claude runs hooks in a sandboxed environment with limited permissions. Google's running them as straight bash scripts with full system access. That's both more powerful and more dangerous.
Wait, full system access? That seems risky?
It is. And it tells us something about Google's philosophy here. They're betting that developers want maximum flexibility, even if it means more rope to hang themselves with. You could literally have a hook that deletes files, modifies your Git history, or phones home to external services.
But from a security standpoint, that's terrifying. What if the AI gets compromised somehow?
Exactly. And this is where the implementation details matter. Each hook is defined in a JSON file that specifies when it triggers and what script to run. Here's an actual example from their docs. You create a file like securityscanning.json with the event type pre-tool selection and point it to your security scanning script.
And the AI can't modify these hooks itself?
No, that's the key safety feature. The hooks exist outside the AI's control. It's like having a supervisor that watches everything the AI does and can intervene at specific points. But here's the performance angle. Google explicitly warns that these run synchronously. Every millisecond your hook takes is a millisecond added to the AI's response time.
That could add up fast if you have multiple hooks.
I did some back-of-the-envelope math. Say you have 5 hooks, each taking 200 milliseconds. That's a full second of latency added to every interaction. For a developer in flow state, that's painful.
So there's a real trade-off between safety and speed.
And that's where this gets philosophically interesting. Anthropic, with their focus on AI safety, sandboxes everything. Google, traditionally more focused on performance and scale, gives you the rope but warns you about it. It's almost like watching 2 different philosophies of AI development play out in real time.
What about the actual use cases beyond security scanning?
Oh, this is where it gets fun. Imagine a hook that automatically adds relevant documentation to the AI's context before it responds, or one that tracks which files the AI touches and automatically creates a pull request. Or, and this is clever, a hook that adjusts the AI's temperature parameter based on what kind of task it's doing.
Wait, you can modify the AI's parameters on the fly?
Through the context injection hooks, yeah. You could have a hook that says, if the AI is about to modify authentication code, drop the temperature to 0.1 for more conservative suggestions. That's powerful stuff.
But is anyone actually doing this in production yet?
That's the million-dollar question. These features are so new that we don't have good beta on adoption. But I've been lurking in the GitHub discussions, and developers are already sharing hook recipes. There's one for automatically running PyTest after code changes, another for enforcing coding standards.
So it's becoming like a plugin ecosystem.
Exactly. And that might be the real innovation here. Not the hooks themselves, but the ecosystem they enable. Stick around because in our final segment, we'll talk about what this means for your team and how to actually implement this without shooting yourself in the foot. So let's talk practical implementation. If you're a platform engineering team looking at this, where do you even start?
Yeah, because this feels like one of those features that could either transform your workflow or become a massive time sink.
First principle, start small. Don't try to hook everything on day one. Pick one critical safety check, maybe a secret scanner or a basic linting check, and implement just that. Get a feel for the performance impact, see how your developers react.
What about the performance concerns we talked about? Any ways to mitigate that?
Absolutely. First, make your hooks async where possible. Instead of blocking to run a full security scan, have your hook quickly queue the scan and check results on the next interaction. Second, use caching aggressively. If you're injecting context, cache that context between runs.
That makes sense. What about team adoption? This seems like something that could face resistance.
Great point. The key is to frame it as enhancing the AI, not restricting it. Show developers how hooks can make the AI smarter, like that context injection example. Hey, now the AI automatically knows about our internal APIs is an easier sell than now the AI has to pass security checks.
What about the bigger picture? Where does this trend lead?
This is where it gets really interesting. We're watching the birth of agentic development, AI that doesn't just suggest code, but actively participates in your development workflow. Today, it's hooks. Tomorrow, it might be AI that automatically create pull requests, runs deployments, even participates in code reviews.
That's both exciting and terrifying.
Right? And here's my hot take. This rapid feature copying between Google and Anthropic, it's actually good for the ecosystem. It's preventing vendor lock-in. If you build hooks for Claude, you can port them to Gemini in minutes. That's huge for adoption.
So what should teams be doing right now?
3 things. First, experiment with these tools in a sandbox. Both Gemini CLI and Claude Code are free to try. Second, start documenting your team's common workflows, which ones could benefit from AI integration. And third, and this is crucial, establish governance early. Who can create hooks? What's the review process? How do you audit what the AI is doing?
That governance point is huge. I can see this getting out of hand quickly without proper controls.
Exactly. And here's a specific recommendation. Create a central repository for approved hooks. Treat them like you treat infrastructure as code. Version control, code review, the works. Maybe even create a hook registry where teams can share validated, tested hooks.
Oh, like a corporate NPM for AI hooks?
Precisely. And that leads to my final thought. We're at an inflection point. The AI tools are becoming powerful enough to be genuinely useful in production, but we're still figuring out the patterns and practices. The teams that figure this out first will have a massive competitive advantage.
Any predictions for what comes next?
I think we'll see OpenAI respond within weeks, not months. They can't let Google and Anthropic own this space. But more importantly, I think we'll see hooks become table stakes. A year from now, any AI coding tool without programmable integration points will be considered a toy.
So the message is clear. Start experimenting now, but do it thoughtfully.
Exactly. And remember, this isn't about replacing developers. It's about augmenting them. The developers who learn to work with these AI agents, to program them through hooks, to create workflows that combine human creativity with AI capability, they're the ones who will thrive in what's coming next. The future isn't AI versus developers. It's developers with AI superpowers. Before we wrap up, let's catch up on this week's infrastructure news. There's a critical security development that every AI developer needs to hear about. NVIDIA just published guidance on sandboxing agentic workflows, and the risks they're highlighting are pretty sobering.
What's the main concern here?
It's about AI coding agents having command-line execution with user-level permissions. According to NVIDIA's developer blog, this creates a massive attack surface that we haven't fully addressed yet.
So we're basically giving AI agents the keys to the kingdom without proper safeguards?
That's exactly the risk they're warning about.
Speaking of changes, OpenAI just announced they're retiring several older models from ChatGPT, including GPT 4.0 and GPT 4.1 variants.
Right. The retirement date is February 13th, 2026. OpenAI says the newer models have incorporated all of the improvements, so it makes sense to streamline their offerings.
This seems like a natural evolution as the technology matures.
Now, here's something unexpected. Reuters is reporting that Elon Musk's companies, SpaceX, Tesla, and xAI, are in early merger talks.
Wait, how would that even work? These are completely different industries.
TechCrunch reports the scenarios include SpaceX merging with either Tesla or xAI, possibly ahead of a SpaceX IPO. It would consolidate Musk's empire in an unprecedented way.
The regulatory hurdles alone would be massive.
Shifting to biotech, In Silico Medicine just launched something they're calling Science MMAI Gym, essentially a training infrastructure for drug discovery AI.
A gym for AI models?
According to Genetic Engineering News, it uses supervised fine-tuning and reinforcement learning to dramatically improve how LLMs approach drug discovery tasks.
That's a clever approach to a complex problem.
And finally, Amazon is reportedly in talks to invest a staggering $50 billion in OpenAI.
$50 billion.
That would value OpenAI at $830 billion, according to TechCrunch's reporting.
What's fascinating is Amazon already has deep ties with Anthropic. This would be a major shift in their AI strategy.
The AI investment race just keeps accelerating.
That wraps up this week's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.